This discussion shows you some of the basics of building the economics template. If you remember, when you looked at the distillation module information about binary going to multi-component models, we talked about balancing the reflux ratio and the utilities of steam and condensing water to the number of stages in a column, and showed that there was a trade-off. If you have very low reflux ratio, you need a very tall column. If you have a high reflux ratio, then your utilities start to go up in terms of cost. And so we want to be able to find an optimal place to operate the column. We're going to do that by applying an economics template. What I'm going to do now is give you a preview of what is in the template, and then we will do a live demonstration actually going through a template, putting items into the template panes and generating cash flow and generating information that can help us optimize our particular set of unit operations. So here we go. This is based on a template which is generated by Peters and Timmerhouse. They have about 160 pages on economics in their textbooks. This template reduces this to about 6 different panes in an Excel spreadsheet that you can use and apply to many of the problems that we will do in this class. So here's an example. If you remember, we were talking in the distillation piece on a separation which included a tower. So here's the feed coming to the tower. We don't know the number of stages. This can be a variable. The reflux ratio is going to change how much condenser cooling water we use, how much reboiler steam we need down here. And if you remember, we need to be able to plot what the costs are. The temperature profile for this particular column is it was initially designed for 10 stages. It shows the temperature going from 70 to 87. This is for a specific simulation. Generally, we would like to have this relatively straight. This is not a bad temperature profile, but it might be improved and provide a better cost simulation if we can do it well. KimCAD is going to give you information on the tower feeds. Here's an example of a stream specification for the feed. This is the stream number 2, and let's go back here. Stream number 2 is the distillate. So this is the distillate stream. Here's the temperature of the distillate. It's 72.7, lower than the temperature of the bottoms at 88.9. You see that the feed is coming in at a condition of 20 C, which is much, much less than the temperature in the column. This is probably not good, and we probably need to think about heating this feed up somewhat. Notice that the pressure of the feed is higher, and we have the flow rates of methyl alcohol, isobutanol, and butanol as shown here. So we have column information. Now we need to put it with cost information to put together the data that we need to optimize the system economically. So here are the general needs we have for economic analysis. We're going to have to get capital costs. We're going to have to generate raw materials and product values, product costs. We're going to have to determine operating expenses, utilities, labor, cost of having the plant, taxes, depreciation. We will have to do cash flow analysis because there's time values to money. And remember, the capital and operating costs have different timings across the plant life cycle. We are going to use this costing method continuously through 455 and 456. I do need to point out that the company you're working for will have its own economic analysis methods tuned to its product mix and its industry type. They will undoubtedly be different than the ones we are presenting here. We're going to try to use the same ones throughout these 2 semesters just so that you get used to using one method and applying it to new processes. So here are the templates, and the templates for 2017 is about the same as the one for 2016. It's got 6 tabs to it. It's got a raw materials cost tabs. Here we can also put in utilities and product values. It has a purchased equipment cost, PEC table. It has a total capital investment table. What do we have to buy physically that we can depreciate to put this plant together? We then generate the total product cost, which is both operating costs and capital costs rolled into one number. We can generate a cash flow sheet that shows you when investments need to be made and when we're going to get money out of the process. This can then be turned into total cash flow plots, which we will use to make decisions. In general, on this template, input cells have red letters. Cells transferred from other tabs will have blue letters. You don't want to change the blue letters. You would rather go back to the prior tab, change the computation there, and have that sent forward properly to the tab that you're working on. Here's an example of the Excel spreadsheet for the raw materials costs. So I happen to have 3 raw materials here, methanol, 2 propanol, and butanol. I have the cost of 1 in there. Normally I'd put in $1 per kilogram or $1 per mass, the number of kilograms I'm going to need per year, compute the total cost, and maybe put in a comment. And in some cases, you may have some consumables that have to be put into this. The next tab down here is the purchased equipment cost. So let's go there next. Again, there's a project name, here's the purchased equipment cost. We know we're going to have a distillation column, for example. There are some other items that could be in this list. We can add process equipment, the sizing and the costs on the rows. We take a sum, and then this total is the purchased equipment cost. It is now put into the next tab, which is the capital investment tab. Okay, so in the total capital investment tab, we have purchase equipment cost. Then there's some other things we are going to need to spend on in order to install the equipment, etc. These are called direct costs, direct capital investments. And then there's fixed capital investments. For example, every plant needs to have, just about every plant needs to have an office. It needs to have, be on land or be rented in a building, etc. So they're indirect costs. You might have to have accounting. That might go as an indirect cost. We will generate something called the total capital investment on this page. We'll also call out working capital, which is the materials, equipment needed for plant startup or working inventory. For example, if we're going to start up something that has lots of distillation, we'll probably have to buy some solvents to put them into the columns to start the plant up. That would be working capital because we can sell those items if the plant closes down. We can sell the solvents back on the market. So the total product costs page has got to the very top of it. I'll show that in a minute. But at the very top, it's got items from other tabs. So it's got a material cost. It's got items from the total capital investment tab, and there would be direct cost, fixed capital investment, total capital investment, lands and buildings, etc. These happen to be from a membrane coating process designed in a prior class. So here is the total, the manufacturing cost for total product cost. It's got direct production costs in it, raw materials costs, operating labor, direct supervisory and clerical, utilities, maintenance and repairs, operating supplies, lab charges, patents and royalties, and then the fixed charges of depreciation, local taxes, insurance, rent, and then something associated with the plant overhead. In general, we will not know these very well at our stage of design. So what we're going to do is put in cost factors. On the range to the right-hand side is a list of 1 to 10 cost factors. 1 to 10 is the list of the items that we need to buy. 10 is the list of the items that we need to sell. 1 to 10 is the list of the items that we need to sell. 1 to 10 is the list of typical range for cost factors. For example, raw material costs in the chemical industry typically run between 10 to 50% of the total product cost. So if we didn't know what the total raw materials costs were going to be for a particular process, we would take a guess. We could put a number in that box and automatically calculate raw materials cost. In this particular case, operating labor we don't know it for sure, we've guessed at it. Operating labor runs between 10 to 20% of total product cost. This is a distillation. It should be at the low end. These are pretty easy processes to run. We put in 10%. Direct supervisory and clerical. We're, again, put in a low number. This is a fairly simple place to run. So all these things in red are items that are guesses on our part. And we generate then the total cost per year to run this plant. This happened to be a membrane coating plant for about $400,000 a year to do that. Okay, now we're adding a couple more general expenses. We have administrative, distribution and selling, R&D, and financial interest. We're adding this in. We get the total product cost. We're also going to put in a profit. This plant will make money. Typically, your company may say we want to make 30 to 40% on gross earnings. In this particular case, we've said, okay, we're going to make 40% on gross earnings. We have put that number in there. We've automatically calculated what the earnings will be per year. So we must get then, for product revenue, we must get over $500,000 a year for this membrane coating process. That puts the sales price at $2.21 per square meter. I've also put down here the total production in terms of square meters of the membrane. So we generate this number, we put in how much we're going to make. This tells us what the selling price needs to be in order to generate a 40% gross earnings profit for the company. Okay, cash flow is done the following way. We're going to, we've got all these coming from other tabs. We've got fixed charges. You remember some of these as being depreciation, local taxes, insurance, etc. General expenses, working capital. This is something that needs to be paid for up ahead. The yearly product revenue. Once we have those numbers and the capital investments, we're ready to do the cash flow. So here is the cash flow. Here's the fixed capital investment from another tab. Working capital. Total capital investment is then $642,000. The first year, if I run at full capacity, that's a challenge, but let's suppose I could, $557,000. Gross earnings of $150,000. So fixed capital plus work capital there. The total cash flow is negative because I've generated a profit of $159,000. I've spent $642,000. So I made money, but I haven't paid back my initial investment. And so you see that it's not until year 5 in this particular scenario that we pay back the investment. Today, many companies are looking for investments to be paid back. This would be the payback period to be 2 years or less. So this particular scenario would not pass economic muster at many companies today. It's a little bit easier to see what's going on if we take a look at the cash flow. The year is shown here, year 0. Year 1, it takes 1 year to build the plant, so year 1 is when I start to generate cash flow. I generate the same cash flow, and here I show spending money on the plant again to buy new equipment, although that could have been flat. I could have said, well, I've got the depreciation budget, and then that I'm going to spend on the plant. The items in red shows you the total cash flow, and again, you break even in year 5, and then you make money, and then you spend money on replacing equipment, and then you really do a much better job of making money. This is equipment being replaced after tenure. So this is an example of what you're going to try to put together to show the economics of your process. This one is okay, but it's not great because it's got a very long payback period, and probably you would be looking for ways to move this red curve to the left so that you pay back the plant sooner. And with that, we have covered the TPC template. We will now go to an online demonstration of how you actually put the data in.